There was a paper from Imperial College, and it had some interesting information. So I tried to apply those information to the SIR model, because if you remember, the SIR model had a really high R0, something like 9.5 or something like that, which was hardly believable. At least it was very, very far away from anything else done by the experts. So, well, we can probably assume that it's wrong. So I started making a new model, and basically adding something else, adding in particular the incubation period, that is the number of days before a person starts to spread the disease, which according to this paper should be around 6 days. And too bad that after I did this, this changed the growth, which with the beta that we used before, it wasn't anymore a growth of 35%, but it was lower. So I had to change the beta. And then when I changed the beta, yes, I could get the growth again at 35%, except that now the R0, it grew from, 9 to 25 or some absurd number. So I decided to share it, not because I actually think that this is actually a realistic model, but it's kind of interesting. So, well, and hopefully at some point we'll get someone who is really an epidemiologist, and he might actually say if what in our approach is wrong. I haven't been doing videos for a while on this topic for one reason. Basically, the amount of data, basically the kind of data that we are receiving is so noisy, so fake, so full of error, that making any models is pretty much meaningless. So I'm not very keen of losing a lot of time on that. But recently, a paper from the Imperial College just came out, trying to estimate the number of infections in European countries. And it's a really good paper. And interestingly enough, one of the elements in this paper is the average time that passed between one person getting infected and he becoming infectious respect to other people. I mean, being able to actually infect other people. And apparently this number is about 6. So I wanted to update the SIR project and with this data, because this actually does change the R0. So basically that's called the incubation period. And so we place it at 6. And of course, this means that once we are actually on our SIR disease dynamics page, we must change the formula. So this changes the dynamics, and then of course we need to actually re-update the whole thing. So let us, first of all, let's try to find again this beta. And we still want a 35% growth. The actual growth is around day 90. And around day 90, we want to have about 35%. Now to have 35%, we need in this hypothesis to have a beta of 2.1. The problem is having such a high beta would bring their zero even higher, I mean, to something that I've never even heard. So there must be an error. I mean, this is where I'm just a mathematician. This cannot possibly be. I mean, an error zero of 25. I never even heard that was possible, to tell you the truth. Well, the total number of deaths isn't much more, and the good news is that it would be very, very fast. So you see how it actually is growing at the same speed as the actual number of deaths that we observed. So let's try to optimize it. Let's see what would actually happen. So I've added this, which is number of real versus recorded death, because recently there was an article showing there are some data from the Italian Institute of Statistics, which are basically saying that the actual number of deaths for coronavirus might be much higher, because there's many more people that die that are not recorded as coronavirus death. But if we look at the number of people that die on average in this period respect to the number of people that die on average in the previous period, previous years, it's just much, much more. So So for now we stop here. What is impossibly high is this R0. I mean an R0 of 25. I think I've never heard of something like that. So there's obviously something wrong in those data. I'm trying to fit with the data that I receive, which is of an incubation rate of 6, of an incubation of 6 days, but apparently having an incubation of so many days just does not seem to fit a growth of 35%. So this is basically why I'm not making any more videos at the moment. We're gonna make some videos about finance where we actually maybe have a little bit more data and it's a little bit easier maybe. So what do you think? Is it worth continuing to study the SIR model? Should I just move on and do something else about it? Let me know in the comments.